So today on my bench I've got a Champion, Fender Champion 300, and as far as I can tell it's very similar to the Champion 30, and there's the back there, and I bought it from the closed down McNally Smith College of Music, but it was in their repair shop. It was not working, and it looks like somebody was just using it as a cabinet because they hooked a jack up to the speaker, and so apparently the amp wasn't working at all. So I took it out of the case and I'm going to see if I can figure out what's going wrong with it. So I'll start by just setting up my signal generator to go about 20 millivolts, and I put that in the front jack. Then I'm going to hook the speakers up to this giant resistor, just an 8 ohm resistor, and instead of a speaker, just until I see what's going on, and then I'll hook my scope up to the speaker as well, just to see what's coming out. And then when I plug it in, I'm going to plug it in through here, which is just a dim bulb tester, so if it draws too much current, it'll limit that current. Okay, so now I'm going to switch it on. Okay, there it's on. Yeah, that doesn't look good. Yeah, that's not looking good. Something terrible's happening there. Let me try this. Yeah, and when I switch over to channel 2, which should be controlled by these here, I'm seeing the same thing. The other thing too is that it's 29 volts and 9 volts RMS. So that's let's see. So that's 9. So that's 9 times 9 divided by 8 equals, so that's about 10 watts that it's pumping out into that. This is with the input completely shut off. And so I'm going to try to figure out where my signal is getting screwed up and what's happening here. So as I'm looking at the schematic here, so both our inputs kind of come through this coupling capacitor right here, and then they come in through here to this op amp right there. So that's the first thing we want to check for signal. So we'll just make sure that the signal is getting from here to here, and then check pin 3 of this op amp. And this is a dual op amp, so it looks kind of like this, and like that, and like that. And this side of the op amp is right here, and the other side of the op amp is right here. So you can see what, after it comes out of the one half of the op amp, it comes down into this other one, and so this is one direction, and that direction comes all the way through here. And if you're, so this represents one of the channels, and then here's this JFET here that pretty much when the switch is pushed in, it grounds this if this channel's turned on, and if this channel's turned on, this JFET grounds it right here. So this is how you're switching between the two channels, these two guys right here. And so the one channel goes through this kind of tone shaping here into another op amp, and then eventually they connect up down here and then head off over into more tone shaping and a couple more op amps and into the effects board. But we'll check this part out first and see how far we get. Okay, so let's switch it on, and we've got our signal here, and then let's check pin 3, which is a signal coming into the op amp. Oh, there we go. Looks good. And then coming out of the first op amp is pin 1. And there we can see that it's jumped from 200 millivolts to about 820. So it's really made a big jump. And so that then next we're going from the output of this op amp into this second op amp, which is in the same chip. So let's check our pin 7. We'll check our pin 5 first to see what's coming in, and then we'll check pin 7 to see what's coming out. So if we look at 5, we have the signal coming in. It's a little bit attenuated, but if we look at 7, we have a signal of about 2 volts. And let's also, just for grins, let's check what our voltage coming into that op amp is. -6. And 6. So I'm going to pull the DSP board, and that's going to isolate it before the power amp. So if I turn it on, you can see that the signal here is right around 39 volts, so it's almost as high as it can go as far as output goes. And but if I pull the DSP board, it drops off. So whatever problem we're having it before that part of the circuit. And I think now if I look at the voltage seemed low. Yeah, now if I look at it, it looks just fine. It should be around 15, I think. Yeah, it's 15 there, and -15 there. But I think that when I have this hooked up, it's using up so much power driving full output that that we've got big problems. So I want to check the voltages on, or match up the voltages on the board with the voltages here. And so it's 20 millivolts AC, and that's about, I think, and that's 60 millivolts peak to peak. And so I'm going to take a look at that my voltages match up, because I still am very suspicious of that first op amp. So if I look at the scope at the output of that op amp, we have (232 millivolts going in, and 260 millivolts coming out, and we've got this weird jaggedy noise on there as well. So I'm going to pull that op amp and see what a difference that makes. Okay, let's see what we got now. Okay. Look at our power going in. Okay, about 20. And our power going out the first op amp. 80, and then the power going out of the second. 80. What? Okay, mystery solved. So the problem I was seeing is that the output here was no higher than the input coming in. There's no amplification happening here. And so I felt like it was somewhere in this network in here. And so I pulled this resistor right here, and it made no difference. And so then I pulled the potentiometer completely out and tested it, the volume potentiometer, and it was working fine too. So, okay, and so the volume wasn't working, and so I took the potentiometer out. It seemed fine, and so then I put it back in, and I noticed that these traces were very loose where the potentiometer went in. And so if I check the resistance to ground, right here it's 0.3 ohms, which is good. But then when I come here, it's 48 kilo ohms, and then here it's bad too. And so this is the center of the potentiometer. That has to be grounded according to the schematic. And what's happened is right here the trace is cracked. And so I'm just going to run a jumper straight over to here, and maybe even down to here, and take a look at it. Okay, so here's our jumper in place, and all I'm doing is taking that center pin of the potentiometer and bringing it over to ground. So now I'm having a problem with so I just have a small signal coming into here, and then if I look at the output right here, it's saying it should be about 147 millivolts, but it's actually around 380. So if we look at that on the scope, oops, turn it on, that helps. So if we look at that at the scope, yeah, we're 470 millivolts RMS, volt and a third, peak to peak. And then look at our output is cranked almost all the way, and if I turn the volume knob past 2, we're starting to clip already. The blue line is our output. This is off our third op amp, and we're starting to clip already. So I'm going to try to figure out why that particular op amp is putting out so much, is amplifying so much, and it's right after the tone section. Okay, so this is my bass. The reason I'm looking at the bass is because the bass is actually grounded right here, and that if that we're not grounded properly, that might affect how this is working in here, and it might up the gain here. And so I'm looking at this, and if I look at this pin right here, which should be to ground, it's half a meg to ground, and then I started looking at this, which should be grounded. It's not. Looked at this, which should be grounded, nothing. Looked at this, should be grounded, nothing. And then looked at this, and it's good. And I think what that means is that right in here, the trace is fine there, but the solder joint itself is not. So we've got another broken trace right in here. And so I think if I fix that, that might help this gain problem. Okay, so there's my jumper. It's just bringing the ground from here over to here, then making sure it gets down to there, because right in here the trace was broken. Okay, now we're looking a lot more reasonable. We've got, if I go to pin 3, whoops. If I go to pin 3, I can turn it all the way to 10, and we don't see clipping, which we shouldn't on this low a signal. If I turn it up, then I can, but here we're running at 33 volts, so everything looks great there. And then if I put on the drive circuit, get this beautiful distortion. We can adjust the gain. So yeah, everything looks like it's working great. And it was those, the truth of the matter is I was really thrown off course by that op amp that looked like it was bad, and it was really just the grounds going to the gain, to the feedback circuit on the op amp, and the grounding for the bass that was the feedback, part of the feedback for one of those final op amps. So one thing I had to kind of remember when I was looking at this circuit is that if you're looking at tube circuits where you have the signal path kind of coming through a tube, and then the volume is kind of really just attenuating that signal coming through, and a lot of transistor circuits are kind of similar, and obviously these are very simplified and would not actually work, but the signal's again attenuated before it goes into the next transistor. So with an op amp it's different. So with an op amp, you have an input and you have an output, and then you have feedback coming back as one of the inputs. And really, the lower this is, the less amplification you get, and the higher this is, the more amplification you get through this op amp. And because this is using feedback, it's not like over here where you're just, it's as if you have a hose and you're pinching it shut. Here it's you have to think a little bit about how this feedback is controlling this op amp. Anyways, so that's just something to keep in mind when you're working on these op amp circuits. So the bottom line is that the amp's working now, it's working great. It's a fantastic sounding amp. I was really happy with the sound. And so just to demo the amp, I have my son who's an actual musician. He's gonna just demo it a little bit, so enjoy, and if you like the video, please subscribe.